Emma from Tunnels and Tunnelling International magazine. I come up to Newcastle to pay a visit to the new Tyne Tunnel. If you take a look behind me, you'll see formwork being done by RMD Kwikform. Turn the other way and you'll see a section of tunnel being SCL'd, spray concrete line.
My name's Paul Lawton of RMD Kwikform. I'm the Senior Sales Representative for the North East of England. We're on the Tyne Tunnel second crossing, and this is the RMD Kwikform R700 Suffolk Traveller. The 21 metre long unit is actually made up of 3 sections. The centre leg of each is a hydraulic leg, and this means that you can actually lift the system up on the hydraulics, adjusting the height. One of the key points of the travelling system that we've developed is to suit the height changes within the soffit. As you can see from the rebar that they fixed for the next bore, the change in gradient becomes quite significant, and it makes quite a big difference in the leg makeup. The reason it's in 3 sections is to allow for a little bit of articulation, because as the tunnel goes up, it gradually curves around. So you need the adjustment between the units, so you can make this side slightly longer, the other side slightly shorter to go around the corners. We have a special bracing there, and that asks for ease of adjustment, and as opposed to using push-pull props where you'd have to take out sections and add sections. These have been made specially so that they can be quickly adjusted to take into account the difference in height. This is a section of Megashore on the side of the main Megashore leg. The caster is so obviously you can move the system along on the rail. The axle is a sliding axle, which gives you a bit of tolerance for moving to take up any tolerances in the width of the tunnel itself. We're now going to see the hydraulic legs in action. The hydraulic rams run right from the top there down to here, giving a huge amount of adjustment. What will happen is the leg will be lowered, and the load taken on this hydraulic leg, that will then release the load from the adjoining Megashore legs so they can be retracted. The system will then be lowered down onto the casters, onto the rails, which means that then it can be pulled along to its next position. We're pulling up a hill here, so from a safety point of view, it's important to have some method of stopping the thing. If anything went wrong, something snapped, the whole thing could just roll back down the hill, go straight through the wall at the bottom and into the river. So every now and again, they move these steel wedges up behind the roller, and that's just a fail-safe to stop the thing rolling away. The north side of the Tyne Tunnel has been designed on the top-down construction method. This means that the roof slab can be cast on the ground, then excavated underneath, and then the partition wall poured afterwards. RMD Kwikform came up with the idea to suspend the formwork from a system of rails hung from the soffit. These are fixed into casting anchors. You can see the chains suspending the formwork from the channels. As you see, the outside shutters in place there. There are dowel bars coming out of the roof slab to locate the partition wall. Then there's a series of holes cast into the roof slab. This means that the concrete can be poured down through these holes. Once the pour has been completed, the formwork is stripped, When they've been suspended, it's then pulled past the previous pour. The face is then cleaned and treated and put into position ready for the next pour.